Hello, my name is Makai Agigi.
Hello, I am Lucas Brown.
Hi, my name is Douglas Tuttle.
Hi, I'm Sean Zincraft.
For our problem introduction, leveling a plot, development, or otherwise can be hard work, as well as a costly and cumbersome endeavor. We are developing an automated solution with our robotic swarm to aid in excavating and leveling plots of land. Our Unearth excavation bots are designed to fill a range of landscaping needs, including residential foundations, commercial development, municipal infrastructure, and large-scale mining products. In its current form, excavation work is a labor-intensive task, typically requiring a suite of large, expensive equipment operated by skilled tradesmen. And while these tradesmen may work together in some manner, we believe that we can make the automated process entirely more efficient. Economically, we are adding value by replacing a time-sensitive and labor-sensitive task with one that could be done autonomously, no matter the time of day or the laborers at hand. Technologically, we're making the practice of operating heavy machinery safer for construction companies and more accessible to those who may want to use our products for terraforming. Our direct customers may include landscaping companies, building developers, mining companies, or state departments of transportation. Really, anyone with some form of terraforming need could use the Unearth excavations. For our indirect customers, we will not be selling equipment to resellers, as our company will be directly overseeing and dealing with our customers. We'll be closely working with them to provide repairs to damaged bots and support the planning and execution phases. We may need to work with companies on lease agreements if their needs are not open. Here is a comprehensive list of the requirements that our bots must be able to fill. Must be able to determine a suitable area for development, must be able to excavate a large area without human intervention, must be able to break through all forms of the rock so that the excavator bots can do their job, must be able to clear vegetation, trees, bushes, and plants of all sorts within the average lot size, must be able to dig at least 8 feet in depth for a basement foundation and 4 feet below ground for a 2-story foundation, as well as able to carve footings as small as 15 inches wide. Must also be able to move greater than 40 cubic yards of dirt per hour. That's greater than the average, and able to move dirt in large quantities, roughly 20 tons. Following list is a description of each of the bots with the team in charge. The Jackhammer bot by Makai Gigi, Trencher bot by Douglas Tuttle, the Excavator bot by Sean Zinkgraf, and the Surveyor bot by Lucas Brown. So here are two perspectives of the Jackhammer bot with the ultrasonic sensor clearly pointed out on the end of the jackhammer here, as well as a top-down view of the jackhammer bot with a width of 30 inches and a length of 40 inches. Here's another perspective of the jackhammer bot. You can clearly see it's 42 inches tall when the arm is at its apex. Here's my circuitry for the jackhammer bot. We have an Arduino with some inputs going into a motor bridge here, as well as 4 DC motors down here, controlling my tread motors left and my tread motors right. We have some more inputs going into some potentiometers here, which then control the arm movement of the jackhammer, the left and the right movement, the up and the down movement of the arm, as well as the aiming of the jackhammer. My final two inputs, let me go ahead and move my webcam, are a ultrasonic distance meter up here and the vibrational motor for the jackhammer here. Here's my flowchart for the jackhammer. We'll go ahead and start and turn on the GPS module, set up into the neutral position, and ask if the GPS module is on. We'll get the coordinates from the reconnaissance drone and then ask is the bot at the correct GPS coordinate. If not, then it will go through these steps up here in order to move the appropriate location. If it is there at the rock, then we'll go ahead and engage the arm servos. Ask the ultrasonic distance sensor, is the distance less than 8, and engage the jackhammer. We'll then ask the recon drone, is the rock still detected? If so, we'll go ahead and we'll do all of those steps again by coming back to is the bot at the GPS coordinate, and if not, then we'll ask is there another rock coordinate? If so, we'll go ahead and we'll do all that again, and if not, then we'll go ahead and finish. Here's my code for the jackhammer bot. I've declared all of my variables up here and gone ahead and appropriately set them to the correct pins here, as well as a serial output for the distance read. Here are my movement methods, all dependent upon current location and GPS location. So we have movement methods for forward, left, right, and back up, as well as arm control. We have movements for that, and then asking if the distance to the rock is less than 8, we'll turn the jackhammer on, else it will reset into the neutral position. The jackhammer is on, we'll go ahead and ask if the distance is still less than 8, then we'll run the motor. If not, we'll turn the motor off. And else, if none of those conditionals are met, then we'll go ahead and keep the jackhammer off. And here is a video of my code running with no errors.
Hi, my name is Douglas Tuttle. I'm showing you this trencher bot today. The trenching bot is designed to make trenches in construction zones. Trenches are usually needed for conduit and or piping and various other things needed for the construction of a building. The bot is a pretty simple design here in CAD. We have a black box representing the very large battery to power the very powerful chain blade. The battery also acts as a bit of a counterweight to the chain blade because it extends so far out in front. You have 4 sets of treads. The treads were decided upon over wheels for better traction in rough terrain. And inside the green box, we have a housing for all the various sensors and more sensitive material inside the bot. In front of the green box, we have a simple debris shield. This is to better protect the battery and other sensitive components with the debris flying once the trencher starts moving. On either side of the chain blade, you'll see 2 corkscrew-like objects. These will run when the trencher is running. This is meant to direct debris, dirt, and all of that away from the bot so it can continue to move about its course. On top of the green box, we have a dish sensor. This is to get above and higher than the bot to better transmit and receive data from the mothership/recon drone that we have in our system. And the next slide is going to be showing you my circuits and to raise and lower the chain blade so that it can trench. It has a ultrasonic distance sensor to stop the motors should anything come within 500 centimeters of the chain blade. It also has a battery here that is meant to represent the overall battery pack for the bot. Here with the simulation, we can see once it starts that the motors are running. We have the actuator here to adjust the height to raise and lower the chain blade arm, lower it so that it can trench, and raise it so that it doesn't trench. Here we have the external battery and the ultra distance sensor here that will both prevent and allow the function of the motors and the chain blade should something get within 500 centimeters. Here we have the external battery and the ultra distance sensor here that will both prevent and allow the function of the motors and the chain blade should something get within 500 centimeters. Alright, here we have a very simple flowchart for the trencher bot. It's going to start. It's going to turn on its GPS and sensors. It's going to ask if the GPS and sensors are on. If not, it's going to go back to the very beginning and turn on the GPS and other sensors. Once the GPS and sensors are on, it's going to receive pathing instructions from the recon drone. It's going to ask if the bot is at the start of the path. If the bot is not at the start of the path, it's going to adjust its direction and move forward. Once the bot gets to the beginning of its path, it's going to check if there's any objects within 500 centimeters of its chain blade. This is a safety feature to prevent damage to the bot itself and other bots in the area, and people, things, objects, and all of that.
My name is Sean Zincraft, and for Unearth Excavation, I designed the excavator bot. So for mechanical, it is a track-driven excavator, a traditional skid loader excavator style bot. It has 2 points of articulation, both driven by hydraulics, and a camera package with cameras and sensors and whatever other electronics are needed forward facing on the front of the car. On the inside, there is a large battery pack, 2 electric motors, as well as a slot for counterweights. They can hold up to 900 pounds. And overall dimensions for the excavator bot, as well as the internal circuitry, which features an Arduino microcontroller, 2 servos to represent the boom arm and the bucket angle adjustment. It has 2 drive motors represented by these DC motors connected to a L29 3D motor controller. This 9-volt battery pack represents the onboard battery pack that powers the motors. It has a depth sensor for topography mapping, a tilt sensor, and a pressure sensor to detect when the bucket is full. With instructions being received, and works through several different movements of the motor for navigation. Once it reaches destination, it's instructed to begin digging and read the inputs from the depth sensor. Once it reaches capacity, it will again navigate through to the dump location and repeat a loop until it's finished. It also continuously checks for battery voltage. It has instructions for grading the soil if required. For code, the simulation starts by assigning arbitrary values that represent what the survey bot would instruct as the target location to excavate. And it begins a sequence of forward, left, and right motions to navigate to that destination. It lowers the bucket. The motors begin moving forward until the pressure sensor reaches the maximum capacity, which in this case is set to 100. At which point it turns on the motors again and begins to navigate to the target dump location. Once the bucket is lowered, the dump is complete, and then it either loops back around to continue excavating, or if the job is complete, it addresses the survey component and using the depth sensor outputs readings of the depth of the excavation.
Hello, I am Lucas Brown, and this is the reconnaissance drone of the Unearth excavation project. Here we have a topside view of the drone where you see the antenna, the sensors, the propellers, and also the stands. Here we have an underside view with also a view of the camera. This camera would be a LiDAR camera as to detect different heights and depths of the area that is going to be excavated. You also see just how thin this drone is, only being about 2 inches thick at maximum. Now here we have the circuitry with 4 sensors, an Arduino, 4 motors, 2 L293D chips, and a power source. The motors, of course, will control the propellers, with the L293D chips controlling these motors. And then you have the sensors, which will provide input to the Arduino, which will then relay that to the L293D chips. And alongside that, the Arduino is what controls the drone as a whole. Now we have the flowchart, where we have serial begin void setup, begin input from sensors and camera, and then when it goes to the actual input. The first input, of course, is the distance from an object behind it greater than 24 inches. Now, if this is yes, we go into this code here. But if the answer is no, we go into this code here. Finally, we have the code for this drone. Of course, we have the setup, and then we have the more setup because it needs to relay information from the sensors. Then we have the first do statement, which will then determine what these motors will do if the distance is less or greater than 24 inches. And then we have the other do statement will determine what to do if the distance is less than 24 inches. And then, of course, the camera will relay this information and then feed that to the Arduino. And then if the camera determines there's nothing more to record, it'll head back to home base. And that is a reconnaissance drone of the Unearth excavation project.
So here's our collaborative flowchart. We'll start with the reconnaissance bot here, and it will begin setup and begin input from sensors and cameras. All of these conditions here ask if the bot is in the correct place, and if so, it's going to go ahead and send our information out to the rest of the bots. We have the jackhammer bot's flowchart down here, getting its coordinates from the reconnaissance bot. We have the excavator bot here receiving instructions from the reconnaissance bot, and we have the trencher bot up here receiving instructions from the reconnaissance bot.
This is the budget for our project. We have the recon drone that comes in at a total of $586.80. And then the trencher bot that comes in at $364.30. And then the jackhammer bot at $486.5. And then finally the excavator bot at $524.
In terms of what already exists, the concept for automated land excavation does not currently exist. There are some jackhammer bots that are used in certain applications, but modern excavation is almost entirely by humans, manually controlling the large machines. Modern excavation is extremely fast and efficient, making the need to automate the process not necessary but by combining aspects of current excavation processes paired with more automated machines, it could lead to a better, safer, and more efficient excavation process. This project was a valuable exercise in how to think like an engineer, how to examine a problem that requires a solution, and how to implement various strategies to arrive at the best, most marketable solution. If we were to do this project again, we would incorporate more rapid iteration to build on our good ideas and learn from our errors along the way. In summary, we've gone over our bots, mechanical designs, we've gone over our circuitry and our code, as well as our flowcharts, and we've also gone over our team collaborative flowchart, our budget, and what already exists on the market. We believe that Unearth excavation bots are perfectly selected for this task. They could work autonomously 24 hours a day and in any condition until the job is complete. This technology, we believe, will not only outpace the best alternative, it will do so for a lower cost and with a higher degree of accuracy.